Hello everyone, this is Pierre speaking, and today I will present you a joint work with Jérôme Ferenbach and Bastien Kovac. So this is a plugin that is working under IC, and IC is an open source software that allows analyzing biomedical images. Let's open a 3D image. Okay. So this is an image, synthetic image that we designed in order to illustrate the plugin. And you see that it contains ellipsoidal-like objects. This could, for instance, represent biological tissue, and these would be cells or nuclei inside this tissue. And the typical problem in biology would be to segment all these objects in order to understand the geometrical features of the tissue. So to do so, we designed a plugin which is called FitEllipsoid. It's available in the official list of IC plugin. And okay, this is the plugin, so it's minimalist. And when you confirm the sequence, because we want to work with this image, two windows will open. The first one is the one that you already know, showing the 3D objects, and the second one is an orthogonal view. And we will work mostly on the orthogonal view. So now imagine that you want to segment this specific nuclei. How will you do that? The first step is to select the center of this nuclei with the crossbar, and then to lock the window. And then when you left click, you can add points. There are two possibilities to add points. The first one is to just left click, as I already did. The second one is to click shift, and then you will add point continuously. And then you need to do that in each of the three orthogonal views. The best is to put points uniformly around the boundary. So I do that. You need, let's say, at least 5 points in order to get a decent result. Okay, and that's what we obtain. Okay, by clicking play, what the algorithm does is it tries to fit an ellipsoid to the given set of points. Let's see precisely what happened here. So, by clicking on layers, you can remove some layers. So here, that's the image. Here, that's the set of points, and here, that's the ellipsoid. So first, the user selected a point in 3D space with the orthogonal view. Then he clicked on some points, and those points should be located on ellipses in each of the three orthogonal planes defined by the crossbar at the start. And then, given this set of points, the algorithm is able to try fitting an ellipsoid to those points, and this is the result. Okay, and if you compare this to the image contents, well, it's convincing. The algorithm did a good job. Okay. So when you are done, you can check that your result is correct by, for instance, moving this, and you see that you also get the you can see the result in each of the three orthogonal views. And if you're happy, you can continue working by locking, clicking on some points around the boundaries. Okay, and let me show you an additional feature of this plugin. If you are not happy to use only one set of points, you can unlock, change the view. Say you want to add points here, so you can lock, add points in each of the orthogonal views again. Okay. And click on play to finish. Okay, and that's the result. And once again, I think it's pretty convincing. You can check. If it were not, you could remove the last ellipsoid, or remove a given ellipsoid, and the ellipsoid are given by numbers. It's rather faint, but we've added the possibility to see the number of the ellipsoid inside. You see there is a 1 here, and here there is a 0, which allows identifying the ellipsoid. Okay, so that's the first way to cope with mistakes. So let's say you are not happy with this ellipsoid, so you can just remove given ellipsoid, for instance. Then you get a pop-up window. You want to remove the first ellipsoid. Okay. And then you get one less ellipsoid. Okay, let me show you additional ways of correcting mistakes. So let's say I want to segment this ellipsoid again, so I can click on lock, put some points, and if I make some mistakes at points, I can remove them by right clicking. And then I can add points again. Okay, that's pretty accurate. Click on play, and you get another ellipsoid. When you are done, or when you think you are done, what you can do is export the result as a CSV file. So by doing so, you get a pop-up window. Let's say we want to save this under test. And okay, so we get a test.csv file which was created, and you can open it with calc, for instance, under Linux. And here are the results. So you see that you segmented 2 ellipsoids, so you get the names of the ellipsoid, ellipsoid 0, ellipsoid 1, and they are specified either in pixels, either in micrometers. In these examples, the pixels and the micrometers were the same, so there is no difference. But in some cases, what could happen is you have a different scale in the Z direction, and then the results could be different. Okay, then an ellipsoid is given by its center, given by x, y, z, and then by 3 vectors, the first, the second, and the third, which give you the 3 axes of your ellipsoid. Those vectors have a unit norm, and last you get the length of the vectors in each axis, and along each axis, plus the volume of your ellipsoid. And this can be used to make a statistical analysis later. Okay. Another feature of this plugin is to allow you exporting as binary masks. So once again, you get a pop-up window. Let's say we want to save it under test, or segmentation. And then the plugin creates the image, and you can open it, and here it is. Okay, that's the segmentation result. So you can see that it is less accurate than the 3D view, and this is due to quantization effects. So this, if you can avoid using this is better. But in some cases, you would like to use this segmentation result in another plugin, and then this can be useful. Okay, so I'm almost done. Let me just show you a last feature of this plugin. Imagine that your computer crashes, so everything you need to restart your computer, and you think you lost your work. If you segmented thousands of ellipsoids, you might be angry. And in fact, that will not be the case with this plugin, because when you open the same image again and that you launch the plugin detects that you already treated this image previously and proposes you to load the previous segmentation results. And by doing so, you get your results again, and you can continue making a segmentation as we did previously. Okay, so let me do it just to show you. So you click on a few points. Overall, it's good having at least 5-6 points uniformly put around the boundary of the ellipsoid. The more the better, because the most robust. But you don't need to put too many. We really tried to minimize the user effort to make a decent segmentation result. Okay, and that's the result. So you see that here probably I did not put enough points, because the ellipsoid is too elongated. So that's a typical situation where you could be willing to click on remove last ellipsoid and then do the job again. Okay, I think I've shown you all the possibilities of this plugin. We use it currently at ITAV in our laboratory in Toulouse, and our experience tells us that this is about 10 times faster than the best existing software. So we think that it is very useful for the community. If you want more details about the theory behind this, you should have a look at our paper, which will hopefully get published one day or another. Very best regards, and see you soon.